Afternoon, and thanks for watching. Today's March 27th, 2026, and I'm working on developing a stock market model in Python. Before I get to work, I'm going to review the goals for this project, the progress I've made up to this point, and what I'm going to be working on today. I work on this project every day, so if you're interested in stock market models, Python, AI coding tools, or just markets in general, please like and subscribe to follow along on this journey. So, let me pull up the PowerPoint real quick. I have two main goals on this project. The first of which is to beat the S&P 500 by a significant margin and make money in all regimes. So if the S&P is going up, I want to be performing way better than the S&P. But if the S&P is going down like it is now, or we're in a recession, I want to still be making money. So I don't want to be beating the S&P but still losing money. I want to make money no matter what. And if we're going up, I want to do way better than the market average. Now I'm writing all of this in Python, so the secondary goal I have for this project is to generalize all of my code to make a tool that's not only useful for me, but something that anyone can use to create advanced models for themselves. So this is the general structure of what my strategy looks like. First, I have all of the data, I'm isolating a stock universe from that data, and then I'm using that to train the returns model. So you don't want to include all of the stocks in your data that the model's training on. You want to cut out things like penny stocks or low volume stocks because that's just going to make the model worse. Recently, I found out that there are also these things they're like synthetic tickers or something like that. So NASDAQ can test things, so I want to exclude those too. There's some other assets I want to exclude. So you feed those into the returns model. The returns model generates a prediction. You're either predicting the return for the day, return for the next 5 days, return for the next month or something like that. And then, or you could predict like return relative to the average of the market. And once I have a really good model here, then I'm going to incorporate that into a portfolio model, which is going to generate picks based on the output of the returns model. So I started this at the beginning of the year. This is where I was at the end of January. So I started out getting data from NASDAQ. That wasn't going to be very efficient because you need to download a CSV for every day. Better data source is DoltHub data from a guy Post No Preference. I put the link in the description. DoltHub's basically GitHub but for data. And this includes all tickers going back to 2011, including those which have been delisted so we can avoid survivorship bias. And he also updates it every day after the market closes. So once I have a model that's ready to go live, I could just pull the data every day before making the predictions. Once I had the data, I had to clean it up a little bit. So this is accounting for splits. Once I had it, I looked at some basic features like here I'm looking at different fundamental features, how they perform over time. This is showing the performance of different stocks in a sector over time. In this case, it's pharmaceuticals. And this is nice, but it's a qualitative analysis really. And we want something we could automate to make picks every day. And so a much better way to do this is a light gradient boosting method. These are pretty standard for stock market data. They work really well on market data because they handle big data sets well, they handle time series well, and they handle missing values well. All of these are requirements for the stock market model. The next step was to incorporate this into a portfolio strategy. And without getting too far into it, I found something that worked, but it's only working on one stock per day. So here you see Sharpe ratio on the y-axis, number of positions on the x-axis, and the only one that's giving a Sharpe above 1 is if I'm making one pick per day. And you want a Sharpe ratio above 1 that's kind of the baseline threshold for your model to be usable. It probably should be much above, significant amount above 1. I tried, so this model is predicting returns, probability of going up. And so I tried thresholding the probability. If I increased it from 50, I did see a good performance increase, especially at 54%. But if I increased to 55%, it wasn't making any picks. So for these two reasons, because it doesn't make any picks if I go above that threshold, and also because it's only picking one stock per day, I decided this wasn't really a robust model. And rather than trying to optimize the portfolio, I really needed a better return prediction model. And so to do that, I needed to go through and iterate through all sorts of features and targets to use, and also change the models, change the universe, and change my portfolio strategy. The problem was at the end of January, how I was doing this was I wrote a new script every time I wanted to get the universe differently, train the model differently, or implement a different portfolio strategy. That resulted in dozens of files. It was going to be cumbersome for me to use, and it wasn't going to be usable for anyone else, which negates the second goal. I should also say, for the second goal, creating a tool anyone can use. One important constraint on that is it should include only free data. So I want not only a tool anyone can use, but you shouldn't have to plug into an API, pay for it, get an API key and everything. Everything should be free. So I made the new method here. Basically, I wrote some classes for filters for the universe model. I created a universe model, fed that and clean data into that, and then it generated the universe based on the filters. This is really good because it's diverse. If I ever want to add any other filters or somebody else does, you can just go in and write a class, which is a subclass of the filter class. It's really easy and just add it. Next, I built a bunch of feature and target classes. That's what took most of the time for this restructure. And then I created a returns model class. This took all of February. These are all the features and targets that I implemented. Once I had them, I could go through and iterate. So I did this at the beginning of this month, March. So first thing I did was just add all of the features to the model. You can see it's actually performing worse on directional accuracy. But directional accuracy isn't really a metric that you want to look at. I made all sorts of changes to the model. If you're interested in what those were exactly, you can go back and watch the previous live streams, but I'm not going to go through it right now. But basically, instead of directional accuracy, you want to look at these metrics here, the ones that are below directional accuracy. So the information coefficient, that's telling you basically the predictive power of your model. How good is it at predicting? The standard deviation of the information coefficient to information ratio, both on a daily and annual basis, and then the t-statistic. And these last four metrics tell you how stable your model is. So IC is giving you the predictive power, but you don't want just something that's really powerful but fails really poorly when it's wrong. You want something that's stable as well. And since stock market data has a really really low signal to noise ratio, your information coefficient's never going to be that great, so you really have to get good stability. So I found this model here, which is beating my target on every single one of those metrics by a significant margin. And here I'm looking at the decile analysis. So if you plot the return of the deciles in your model, it should look roughly like a staircase, which you can see that it does here. I went through all sorts of ways of testing and making sure this model was performing well. And I basically showed that it was. And when I completed the tests, at the end of all the tests, it was actually giving even better performance than it was before. And so I had this at the end of last week. I thought I was ready to start paper trading, but then I changed the data split for the model. So originally, those really good results were training on the first 60% of the data. Again, it's going back to 2011. So that's maybe the first 10 years or so. Validating on the next 20%, so that's tuning hyperparameters for the model, and then it was testing on the final 20%. And that was how I got the really good metrics. When I changed this, so it trained on the first 50%, validated on the next 15%, and tested on the last 35%, the model performance seriously degraded, and it went from beating all the metrics to not beating any of the metrics or barely beating the metrics. And so this made me think my model's not good enough and I'm going to have to improve it. There are a couple reasons for this actually though. One, obviously I'm using less training data, so the model's going to be worse the less training data you have. I also trimmed down the validation data, so that means the hyperparameter tuning isn't going to be as good and the hyperparameters for the model aren't going to be as good. And finally, I'm using way more test data. And so testing on the last 35% of the data set is roughly about 5 years. So learning a model from 2011 to about 2020, and then testing the model. Oh, first 50%. So yeah, the model's learning on 2011 to about 2018 or so, and then testing since 2020. The market changes, so that's going to make it a hard time. It's going to have a hard time performing there. So the performance here should be worse, but the fact that the metrics fell off was really concerning. So the next thing I did was do a walk forward analysis. I grouped the data into groups of 6 years. The first 4 years was the training data, the next year was the validation data, and the final year was the testing data. So since it was groups of 6 years, I had to start in 2016, and then I was able to walk through to 2025. And you can see this model was actually way outperforming the metrics on each year until 2022 when it fell off for information coefficient, and it wasn't good enough in 22 and 24. It climbed barely above the threshold in 23 and 25, but this indicates that I need to do some more work to get a really good model. You could also see a similar things happening here in the information coefficient to information ratio. That's falling off too, but it never falls off so far that it's missing the metrics, my targets for the metrics. And so what this means is the model's decreased in stability and decreased in predictive power really over this decade, over the 2020s. However, it's still stable enough to implement, but the predictive power isn't quite as good as I need it to be. So there's kind of two ways to improve this. I can add fundamental data. The problem is that's going to be really hard because the data source I'm using doesn't have fundamental data for everything. So I'm going to have to scrape it from the internet somewhere since I want to use only free data sources. And that's going to be kind of an intensive thing. A much easier thing I can do is add sector data. So I've spent basically the last week getting sector data from the SEC Edgar database, and that turned out to be a much more complicated problem than I thought it would be. The SEC Edgar database has a really easy mapping for currently listed tickers, but if I only include those, then I'm going to have a real survivorship bias problem in my data, and the model's going to give artificially high performance. So I don't want to do that. I want to include all tickers which have been dropped out over the last 15 years. And so that proved to be a really hard problem, but I've now solved it on the last stream. So this is kind of improving the performance. So initially I was only getting sectors for 55% of tickers, increased it to 75, increased it to 93, then I increased it to 97. So I'm getting it for almost every ticker. There's certain tickers that, like I said earlier, they're like synthetic tickers, test tickers. That the NASDAQ uses, which aren't real tickers. And so those aren't going to have a sector because they don't exist in any sector. And so that kind of explains why I was getting unknown for these 67 tickers. I went through and added the sector information to the model, but it actually made the model perform worse. And the reason this is because the sectors I was getting were very specific. So I had almost 13,000 tickers. And I had about 800 sectors. And so that's way too many sectors for the number of tickers. And it's way too, fine grain for the sectors. So yesterday I went through and reorganized it. And instead of passing in the micro sector, I was passing in things like, things like this. So the sector would be laboratory analytical instruments. Instead, there's a GICS, Global Industrial Classification, S something, maybe sectors, and there's 11 of those sectors. And so these are macro sectors that I want to put into the model. So this is the running of the most recent model, and I'm getting, rather than getting these really specific sectors, I'm getting these more general sectors here. And so now I'm going to implement these into my model today to see if I can upgrade the performance. So I want to do two things. Right now I'm normalizing returns with respect to the average for the market. I think a much better thing to do would be normalize returns with respect to the average for the sector. I could do that on the target and the features. And the other thing I want to do is just pass the sectors in as their own feature. So that's what I'm going to be working on today. I'm also going to be working on getting a better universe because I haven't really looked at how to implement the stock universe. So I'm going to see if I can improve performance by using a different stock universe. So those are kind of the goals for today. Hey, Javi, is it Javi? Anyway, thank you. So let's get down to business. All right. So I have the macro sectors. Here's what the data looks like. So I'm going to go through and see do I have everything now? Do I have more than 67 or am I still missing 67? Okay, so let's do data frame is equal to pd.read, what do I call this? Sectors 0325, read CSV, and we're gonna read // data / sectors underscore 0325.csv. Import os dot get cwd data retrieval. I did data dot sectors, so we want to do data /. All right, let's look at df, and then we're gonna say df where df dot macro sector is equal to unknown. So now it's just all right, let's get the length of that. $47, so I'm only missing 47. So next I want to look at these 47. What's the deal with these? So I'm, don't want to show that. Yeah. So now let's go here and say the sector code is now working quite well. Get rid of this. I am now missing these sectors. Why are they missing? All right, so let's do df. Let's do that same thing, but I'm gonna do a dot account symbol. Then we'll just get a list. Dot. Yeah, I'll just get the list. Why are they missing? Test tickers. Okay, dot suffix securities. SPACs, blank check companies, delisted acquired companies. Okay, I want to include those. Let's just go. There's not too many of these, so let's look up every one of these and see why are we missing it. So, EBR.B stock. All right, so let's go through. We're going to say for missing in df of df.macro sector is equal to, so let's isolate the data frame or macro sectors unknown. Dot account symbol. First I need to read in symbols is equal to pd.read. What did I save that as? So I have universes, sectors, dot read feather symbols dot feather. Oh, it's in data. So dot / data slash this guy. So let's do symbols. Yeah, so we're gonna say for, okay, let's just go up. I'm gonna do that again, and let's call that missing symbols. Missing symbols is equal to that. Now for missing in missing symbols, print, first we're gonna say name is equal to company name, security name, security underscore name, and so symbols of security name. Okay, we want to do symbols where symbols dot account symbol is equal to missing, and then we want to do dot security name. Yeah.
Dan and I are going for coffee.
Okay.
Into the post.
Not a Red Bull? I have Red Bulls.
No, thanks.
Okay, good luck.
Okay, bye.
Bye. So the name is the security name for that symbol. And then we could say print name missing name. Name, security name, D-type object. Too long. Why is it doing that? Dot security name. I'd agree with that. I really believe in that. Alright, so let's look up the first one. Oh, this guy. Centrice, Electrica, blah, 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 blah. Is a major Brazilian electric utility. So I guess I could, so it should have a sector. So, okay, that's the first one. Next is this one. So that one I don't think should be missing. Money on my mind. Okay, so what is the df dot sector df? So we'll do df dot macro sector dot unique. Manufacturing services, financial real estate, retail trade, mining, transport, utilities, wholesale trade, construction. Energy isn't a sector. Construction, agriculture. Oh, I guess it's a utility. Why isn't there an energy sector? Do these fall into utilities? They know, they know, they know, they know, they know, they know. Fuck them other guys. I even gave them a chance to decide. That's something they know. They know, they know. Money over everything. Money on my mind. Mine. Apologize, it happened over time. These are SIC divisions, not GICS sectors. Oh. So it's kind of outdated. I do have the SIC code. So how can I map SIC codes onto GICS sectors? Team Drake. I'm listening to a Drake song. I didn't even know I was singing that. Money over everything, money on my mind. It's pretty catchy. Tell him I apologize, it happened over time. Drake has a lot of good songs. I need another good song though. Okay, so now I need to map SIC codes onto GICS sectors. I don't know if that's going to be easy. Oh, whoa. I guess that's a hard problem. Da 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 dum dum da dum. Da 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 dum dum da dum. This guy's thinking too. Okay. Mapping standard SIC codes to GICS is notoriously difficult. Hey, Sir Night Night. Thanks for tuning in. What did I miss by it? What? Your friend made the second half? Your friend's a producer? I'll put that on next. What did I miss? Suck dick, dummy. When I call you a slut. It's funny. Because a purely code-to-code mapping is flawed, the most accurate way to map is at the company level rather than the industry level. If you have a list of companies or stock tickers, do not try to map their SIC code to GICS. Instead, pull the GICS code directly for those companies using financial data. Yeah, I'm not doing that. I also have fine grain sectors like this guy. I'm the only goose standing. But I'm not fucking around. Go ahead, fucking hater, push me. In fact, using these fine-grained text descriptions is often more accurate. Industry. How to automate text to GICS mapping for a large data set. If you have a spreadsheet or database full of these fine-grained text descriptions, oh my god, back to the large language models and code. That seems really unreliable. Well, I used to work in hip-hop. What was your job? Audio engineer? That's cool. What a job. When Aquaman drowns and the Human Torch starts swimming, man, I'm a cold soul. Yeah, so what do I want to do? This is going to be kind of complicated. I could just map it onto the macro sector. Um, assess what you think model performance will be with these two techniques. Assess how much worse will my model performance be if I pass, what was it called? Macro sector. Macro sector was North American Industry Classification System. Oh. She might say no to me now, but say yes to me later. A&R/talent management. What does A&R mean? It is cool. This is a good song. I'm not to the second half yet, though. Or, what does it suggest here? NAICS. I don't know why NAICS wouldn't work. Oh, the first half. Well, it did switch to the second half, and the second half isn't as good. It's way more slow. First half goes hard. So hard I'm listening to it again. It's interesting with rap. It's like that's like probably more important than the rapping is the producing. But you gotta be, it takes a good rapper to kind of recognize how to go over the beat. GICS best. NAICS close second. Okay. Captures cloud computing and biotech at the 3-digit level. It provides solid granularity. It's publicly available. It is designed for economic statistics rather than financial analysis. So some groupings are suboptimal for modeling stock returns, but the practical difference versus GICS is small. SIC is worse, but not by much. Okay, so I'll leave let's say, what's today, the 27th? Talent Scout conduit between artist and label. Wait, so is your friend a producer or a rapper? Sounds like he's a producer. Well, I guess he must be a producer because there's no other rappers in this song. What did I miss? That's weird. He made the first half of the song. I didn't know that happened. Yeah, it really is. Rapping's like a part of the equation, but it's not even that important. All right, so today improvements for the future. So since it says SIC won't be much worse, I'm just going to use that. Incorporate other sectors from into sector data, NAICS, easy, use SIC to NAICS mapping. And then GICS is going to be much more difficult. All right, I'll put other stuff there as I go. Yeah, I don't care about that. I don't know, just for these sectors. So I can go ahead and incorporate the macro sector. No, I didn't get into analyzing that. But I need to. So why did the P&L performance I didn't even look at over time. Let's see, market research. Oh, you mean the Sharpe ratio? Why your question? I think initially what you commented was the Sharpe ratio. Why did it increase in 2024? And if you look at the Sharpe ratio, it's roughly the same magnitude as these guys earlier. So why did the Sharpe ratio do so well in 24, but the information coefficient was bad? No, I didn't figure that out yet. Okay. So, we have these. I'm just going to pass them into the model for the feature engine. Next, I need to pull up the code. Model Explorer. Make this full. Portfolio. Advanced models. I need feature engine. Oh, I want to make sure I incorporated my updates from yesterday before I update new stuff. So that wasn't working. This guy, pointless. Sectors, 0325. I guess I'm going to change the name of that to sector info. Sector info. I'll just call it sector info. Hate in my heart. So this is what it looks like. You have the sector, the micro sector, which I used earlier but wasn't working. There are like 760 different ones of these. And then I have the SIC code for mapping later if I want to. So supposedly there's a mapping of SIC code to NAICS. So I'll do that if, that's a to-do in the future. And then I have macro sector. Okay, so sectors info add, pull sectors v4. All right, so I think is there anything else called pull sectors? Data retrieval, pull sectors v3, pull sectors v4, get sectors. Good, I'm just going to change this to be pull sectors. Okay. Okay, so here I'm going to say added sector feature. Commit. Next, pull sectors. Added script for pulling sector information from SEC Edgar. Data slash sectors info. Oh, actually, I don't want to add that. Do I? I don't know. I could think about that for later. But I'm not changing any code there. So now if we go to feature model, feature engine. Okay, now let's go to this guy. So sector is calling static category. What? Sector. If categorical. So sectors. Not that. We want to do sector info.csv. Use account symbol and macro sector instead of sector. Hey, Kusha. Whoa, that is one heck of a name. Hey, how are you? Kusha Grasrivastawa. Kusha Grasrivastawa. I'm good. How are you? That is one heck of a name, man. That's a lot of syllables. Macro sector. People say my name has a lot of syllables. Yeah, macro underscore sector. Merge sectors df onto account symbols. Macro sector. Cast it into category type and map to requested column name. Df of macro sector. I'm making a stock market model to predict returns. I want to have something that's automated, so all I do every morning before the market opens, I run one script. Actually, I want to implement it into a. There's some what are they called? Brokerages where you can automate stuff. So I want to get one of those and just every morning have it automatically run and adjust my portfolio for the day. And it should outperform the S&P by a significant margin and make money no matter what. So if S&P is going down, I don't want to beat the S&P but lose money. I want to make money no matter what. If S&P is going up, I want to beat the hell out of the S&P 500. Kush, nice. That's a lot easier for me to say. Anyway, hi Kush. I have built my own chatbot. Please review it. I'm not going to review your chatbot, but good luck. Okay, so where are we? So give macro sector, drop the raw sector column if a different base column name was generated. So drop macro sector. All right, so now we should pass macro sector as a category, drop columns, macro sector. I'll tell y'all motherfuckers. Alright, so I think that should work. It's as simple as that. Sector info. Yeah. Now the problem was before when I did this, it showed some weird feature for the sector. It wasn't what it should look like. And take care of my people. And they ain't got no love for that. Trophies. Alright, so clean analysis. Model. Oh no, I want to go to Explorers, Model Explorer. And what is it? Model 15. Alright, so somewhere it was appending like log return. Feature engine. So let's see, is log return appended anywhere? Yeah, I don't see it. So I think, let's see how this goes. So now we want to do this, model 15. Universe 1, yep. And let's turn on model 15. Model 15, 1. Hey, KODR. How are you? The coder. Oh, I get it. You're the coder. All right, so now let's go in and run that. Python 3 Model Explorer. All right, so let's see how that does. Now, so I have sector data. Okay, so now I want to write a feature for, when I'm passing the features, I want to be able to normalize to the sector. So how can I do that? Let's think. Normalize to the sector when I pass in the features. Currently, I have several transformations which neutralize features. Nice. Well, it is close, I guess. Liddell. Who's Casey Liddell? Pat LaChapelle. Yeah, it is not too far off. I have several transformations which neutralize features and targets. Never once did I ever think, oh, good, I have a common name. Maybe people will find me on accident. But I guess that is the case, so it's close enough to somebody's name, Casey Liddell. I have several transformations which neutralize features and targets in feature engine.py. In the feature request class, in feature engine.py. So let me look at the transformations. Do they all normalize to the market average, or does it do something else? So feature request, transform rank, demean, binary, regime, CSZ score. So I'm not sure actually what regime does. So if I want to normalize to regime, motherfucker in the room, yeah, you know it's me. Okay, I'll just give it the code. Instead, currently, the code is written. Oh yeah, well, someone else asked what I'm doing, so I'll go over it. I'm here for it, I guess. Working on setting up my VPS, I2PD, and switching all my website shit from Namecheap. Now, I don't know what any of that is, so you'll have to explain it. What is that? I don't know what VPS and I2PD is. I guess Namecheap is some website web domain service you use. Namecheap, that's what it sounds like. Cheap domain names. Get a domain name for cheap. Currently the code is written so that how is the code written? Oh, we have an error. See this crazy life I have? So we're getting an error in line 24 from clean analysis, import everything. Now error in line 21, import LightGBM. Oh, it's because I'm using the wrong conda environment. So conda deactivate, and then conda activate stock market. I ain't picky, but these girls be acting tricky because the situation's sticky. He's a towing and recovery guy. Liddell, Casey Liddell. Nice. Yeah, use me as your background noise. That helps. That makes me look good for YouTube. Then I'll get more subscribers and stuff. Anyway. Yeah, so let's go back to this. Okay. Use calls do not match columns. The columns expected but not found macro sector. All right, what's the name of that column then? So let's do import pandas as PD. Okay, everybody is asking what I'm trying to do, but let me troubleshoot this real quick and then I'll go over it. DF, okay, import pandas as PD. I have to do check some stuff right now. I don't want to get distracted, then I'll forget what I'm doing. I just need to get the right name for the column. So read CSV sector info.csv. Oh, it's in data, so let's go /data/ oh, sector info. So what is this I'm looking at? Sectors info. Yeah, that's it. So, okay, then let's just do .keys. df is equal to that. df is equal to this guy. Then let's do df.keys, macro underscore sector. So that's good. So somewhere I'm calling sector info, I think, instead of sectors info. Yeah, here. Blow this building up. Sector info. Yep, good. So I fixed it. Now this should run. You don't feel it, then it must be too real to touch. Peel the Dutch. I'm gonna make you. Okay, good. It's working. All right, so let me go over real quick the project, where I'm at and what I'm working on right now. So the goal is, oh, I have a slide on it. So I have two goals. First goal, make money in all regimes and beat the S&P by a significant margin. So when we're in a bull market, I want to be way outperforming the S&P, make way more money than the S&P. If I'm close to the S&P or underperforming it, you could just buy the S&P instead. And then also when the S&P is going down, when we're in a right now, I guess we're in a what's it called, correction region. And if we keep falling, we're going to be in a recession. So when the S&P is going down like it has been this whole year, I want to still be making money. So I don't want to beat the S&P but be losing money. The second goal is, so I'm writing all of this in Python code. So I'm generalizing my code and putting it on GitHub. And so my goal is to make a tool that anyone can use. Right now you can basically do everything that I'm doing in like 50 lines of code. And so you don't need to, basically the big obstacle for people is two things. One, getting good data, which is expensive. And two, building a model. Because as far as I could tell, there's no easy to use free tools where you can like create a advanced model for yourself. So that's what I'm doing here. You can get the code on GitHub, download it. Let me know how it works. If you find it useful, it helps me out a lot. If you star the repository, watch the repository, and follow me on GitHub, that helps raise my profile for coding jobs and freelance gigs. Helps me make money. So that'd be cool if you do that. And then the big constraint here is everything has to be free. And so this is the outline for the model. Is I have a bunch of data going back to 2011. I found a really good data source. The link's in the description. I also give on the GitHub instructions in the README as instructions for installing the data. And it's really easy. It's on Dolt Hub, it's called, and that's basically GitHub for data. And this guy updates the data set every single day after the market closes before the market opens on the next day. So the first thing to do is isolate a universe of stocks. You don't want to use every stock that exists. You want to drop out things that are like high volume and penny stocks, because those will hurt the performance of the model. Next, I'm using that to train a returns model. The model should be predicting returns relative to the market. Now I'm trying to incorporate something which will give me returns relative to the sector, yada, yada, yada. Once I have a really good model working, I'm assessing it on some metrics. Once I'm confident those metrics are really good, I'm going to then make a portfolio level model, which will decide how to allocate money based on how the macro features, basically like interest rates and the performance of the S&P, the volatility index, and then also the model output. It will decide all of those things and optimize a strategy for making money. So that's kind of my strategy. I made some good progress. I started this at the beginning of the year. This is my progress from January. I basically got something working, but it was really fragile and not robust. I needed to iterate through all sorts of different features and targets to find a really good strategy. Before I could do that, I had to reorganize the code into something that's usable, easy to use for me, and also usable for anyone else. So that took all of February. And then in March, I started looking through the model. I found testing out different models. I found a really good model here, which I was thinking was working really well. I tested it basically every which way I could think of to test it. And after doing all the tests, it was actually performing even better than it was before. And so I was really confident in that, but then I changed the data split, and then the model got worse. So I had to figure out why. I did a walkthrough analysis to try to figure that out. This was about a week ago, last Saturday. And I found that the information coefficient, I want between 0.01 and 0.02. That's the minimum threshold I'm looking for. And so you see this was basically good for all years until 2022. It fell off. Recovered in 23, fell off again in 24, recovered in 25. So this model isn't good enough to use. I need something a little bit better. So now I'm trying to basically squeeze a little bit more performance out of the model. The two ways to do that are using fundamental data. I don't have a really good data set for that. So I need to, that's kind of what I'm working on now. Oh, no, I'm not working on fundamental data. I'm leaving that out for the future. Right now I'm focusing on adding sector data. So it took a long time, like a week, for me to incorporate sector data. But I finally finished writing a good script for that a couple days ago. I ran that yesterday. It took, I think it took 15 hours to run. So a really long time, but now I have the information. Now I'm trying to see if I add the sector information, does that improve my model enough so that I can use it? Once I get a good model, I'm creating that portfolio level model. And then I'm going to, what am I doing? I'm creating a portfolio level model. Then I'm going to optimize that. Then once that's working, I'm going to start paper trading. I'm going to paper trade the strategy for a month. Paper trading is just you pretend you're trading. You're not using real money, but you see how the model's performing. And if it performs well on paper trading over the month and I'm still beating the metrics on that month, then I'm going to go live and start using real money. So this is, I ran the model here with the sectors as a feature that's incorporated. So everything I've been doing up to this point, this isn't using only price data. Now I've added the sector data, and this is the performance, and you see it's performing worse again. So the information coefficient was 0.02. Let me check the training split on this model. So this is model 15. Oh no, search here. Why did the sector data make it perform so much worse? Yeah, the data splitting is the same. So it's the same data splitting as I was using in the model that performs really well, this one. However, now it's performing worse. So model performance, model 12 performs worse when I add sectors as a feature. So let's look into this. So this is showing the importance of all the features that I have. And so this is kind of confusing because it's showing the sector information is the most important feature. It might be calculating this wrong, because why would it be, why do we have sector log price 1 day forward? I don't know. 1 day features, so it's a feature from the previous day. I have no idea why it's adding log price to that name, so I have to look into that. And then the performance is way worse. Okay, let me cancel out of this window. Then we'll get the rest of the performance metrics on the forward analysis. And this is the model results. So you can see from basically you want, this is the decile analysis. So if you basically divide it into deciles, the worst, the 10 lowest predictions all the way up to the 10% lowest predictions in 10% chunks all the way up to the highest 10%, 90% highest predictions. It should look like a staircase. Obviously there it doesn't. It looks like shit. So I need to figure out what's going on here. But here's an example The model I had, which was working really well, is this one, and that looks really nice. It's not perfect, but you see it's kind of ascending here, and that looks like a really good model. So, yeah, that's where I'm at. Hey, thanks. Yeah, I like Python because it's like easy to understand. It's good for simple people like me. Um, hey, thanks, NGK. Yeah. Yes, I do. I welcome all help. I like help, but I will not review a chatbot. But I do like help. I hate chatbots. Um, all right. So, um, yeah, the sector is giving, when I add the sector as a feature, it's giving worse performance. Now the question is, why is it named that? So let's give it the performance metrics. You will likely get better performance if you only keep the more important features and drop the less useful ones. Um, yeah, but then when I was trying that earlier, um, so this is with the good model, um, and I tried. I think actually I need to redo this because I looked through. I got the correlation of all the features, and I tried a bunch of different methods for dropping out features, and nothing improved it. However, when I realized this is when I had that error in the model. So I think probably I need to do this again. Go through and drop out every feature and see what improves and makes it worse. Um, oh, here's an example of a really nice staircase. Um, yeah. So that this is like a perfect staircase. Each decile should be higher than the previous decile. So that indicates it's a really strong model here. Yeah, so I need to go through and do this again. Um, but it really, if I'm adding, the sector information, that's not going to be correlated to any other feature. I really think that should improve the model. I think I'm doing wrong here because it says it's giving the sector feature as sector log price. And yeah, why the hell is it doing that? Um, so let me look when I'm defining the sector. Oh, here it is. So features dot append sector features. Yeah, sector feature. Features dot append sector feature. So that should be fine. Okay. So I'm gonna say before I want to add the sector neutralization, you should keep the features that improve recall. It depends on your target. Um, okay, let me write that down. It's probably. What do you mean? It's probably because of my target. The target isn't working, or what's probably because of my target? The performance. That the performance got worse. But I'm using the same target, and the target's the cross sectional z-score for the log returns. It seems like that's the most robust target. At least that's like the best performance I was getting when I was trying different targets. That gave me the best performance. I might need to look into that again. I don't know. For the other people, Sir Night Knight's the pro of the stock market models, and he gives me all sorts of great advice. Um, I need to go to the bathroom really quick. I'll be right back. I'm drinking too much Red Bull. Okay, I'm back. All right. So, this is worse. This is basically what I need to focus on troubleshooting right now. So let's think. Let me use my brain. So the first thing to figure out is why is it calling it sector log price? All right, so here is my code for generating features for my model. I guess I'll switch over to my. I'm gonna run out of requests soon, so I'm kind of starting on a new thing, so I may as well go here. Gemini, good. Here is my code for generating features for my model. I thought that adding sectors as a feature would improve performance. However, the performance was significantly degraded. Why is this? I am concerned because the sector feature was called as was named as sector underscore log underscore price underscore 1 day feature. I am worried it is passing the wrong feature. I've included feature engine.py, which generates the features, and clean analysis.py, which contains the model class. Below I've pasted an example. I thought that adding sectors as a feature, I am using sectors from the SIC classification. Below I've pasted an example of what the first few lines of the sector data looks like. I am using the macro sector feature, macro sector column for the feature. Did I say it's from the SIC code? I'm using sectors from the SIC classification. I'm using the macro sector column for the feature. What else could be important? Despite making the model perform worse. Okay, so below that I pasted the output of the model with and without the sector feature. Otherwise, the model is the same. You gotta get open code. I don't know, I tried using free model is better than 3.1 Pro, really? 3.1 Pro is the best model I've found, but that was in January and everything's changing so fast. But then also someone recommended that I use this, Google's like AI coding tool. It's like a fork of VS Code, but it's it confuses the hell out of me, and then I give it commands here, and then it gets stuck and says I couldn't finish answering or something. I don't know what the hell the issue is. But someone else said I should use open code, but I'll look into that after the stream. I spent so much time on that one stream. I don't want to spend the whole stream figuring out a new tool. Also, this is so fast. You write code, so you get it. This is so much faster, really. But it seems like it works really well for writing code. That guy I talked to said he uses Gemini 3.1 for coding. He uses Claude Opus for like planning. So you disagree, sir? What do you use, Sir Night Night, for coding? Do you use Claude? Um, IDE is VS Code. IDE, Integrated Development. Yeah, VS Code. I had to think about what an IDE is real quick. Below that, I pasted the output of the model with and without the sector feature. Otherwise, the model's the same. Alright, what else do I need to add? Despite making the model perform worse, the sector feature was most important when I was assessing the feature importance. Okay, so now I need to add my code files. Work, stock market tool, scripts, feature engine, and clean analysis. And then I also want, no, those are the only scripts I'm giving it. And then I want to give it, okay, so let's say sample sector data. Looks like this. And then model output without sector feature in screenshot. Model output with sector feature is this guy. Okay, then I need to paste the model performance in. Okay, run it. All right, let's see. Tool calling has nothing to do with coding though. Through AI Studio, my guy, and 3.1 actually works amazing through anti-gravity. Oh yeah, I was using that's what I was using, but anti-gravity it wasn't working that well though. Not writing code through a terminal or IDE. Yeah. Well, that's what I want to avoid. Oh yeah, I do. Well, I like to do my own coding cuz well, here basically I'm scared of letting it update things for me. I like copy and pasting things in, and it's way slower. But then when I tried using the IDE, it wasn't working as well. Um, yeah, the anti-gravity was not working very well for me. Um, anyway, um, man, this is going for a long time, so I got to get this to work. All right. All right. You don't need to worry about this strange name. It's passing the correct data. However, your model's performance crashed due to a classic machine learning pitfall regarding how LightGBM handles categorical features, combined with a potential data loss bug. The naming concern. The reason your feature got named sector log price one day forward is due to the fallback naming logic. However, because sector is processed in phase 1.3, fix the data is correct, but to clean up, okay, I'll give it an alias. High importance but terrible performance. You mentioned that sector became the most important feature, but the performance tanked. This is textbook definition of categorical overfitting. Because you correctly cast the column to a pandas category D type, LGBM detects it and uses a special algorithm to find optimal splits. If you have 20 different sectors, LightGBM can group them. What the fuck does that mean? Let's look up Fisher's exact test. Treats categorical features as non-iterative integers. Non-iterative integers. Instead of creating numerous sparse binary columns, the algorithm groups categories into two sets. LightGBM easily finds a random combination of sectors that perfectly memorize the noise in your training returns. Because this split reduces the training error so drastically, the gain feature importance skyrockets. But because sector performance rotates constantly in the real world, these hard-coded groupings completely fail. The hidden universe shrinking bug. Drop NA. If your sector's info is missing even a few of the tickers present in your price data, the left merge will result in NaN values for those stocks. Your drop NA will call then permanently delete. Okay, well, it's calling them unknown, so nothing's missing. It's thinking unknown is a sector. If sectors.csv has any duplicate rows, your left merge will multiply the rows in your main data frame. It shouldn't have any duplicate rows. Update your loading block to prevent duplicate explosions. What the fuck is a duplicate explosion? Okay, that's not happening. Alright. Where's data frame? I was looking at. What is that? Oh, I forgot. I think I'm doing the walkthrough analysis too. Yeah, it's doing the walkthrough. Okay, what did I want to look at though? Oh, how to see if any features are missing from my data frame. Hey Garuda. I'm basically building a coding tool to predict stock market returns. The goal is just run a script every morning before the market opens and then automatically adjust my portfolio accordingly. And it should work so that it's always beating the S&P by a significant margin. And also so that if the market's going down, I'm still making money. Those are my requirements. And then I'm generalizing the code so that anyone can use it, putting it in a GitHub repository. You could find the link for that in the description. Yeah, basically I want to make a general free code tool that anyone can use to make models for themselves using the same tools I'm using. All right, so Tame LightGBM. You need to force LightGBM to regularize categorical splits so it can't overfit. Inside of tune params, add strict categorical regularization. I mean, this stuff is all to handle missing features. So I'm going to add this into the model. Okay, so clean analysis, model, tune hyperparameters. Got my mouse pad wet. Yeah, it's public. You could get it in the description. Please, it helps me out a lot if you star it, watch it, and follow me on GitHub. I would appreciate if you did one or all of those. But yeah, you can get it, and you could run. Basically, you can make the same model that I'm currently making, or the model I'm currently making is using a lot of features, but you can isolate a universe from your data. To create the universe to train on, create the model, and then test your model in all sorts of ways. You can do that in under 50 lines of code. And if you want to add a lot of features like me, it might take a little bit more than 50 lines just because you need a line for each feature. But yeah, it only takes a few lines of code, and you could use a chat model to help you do that. And you can kind of iterate through and create your own model. What is this? Oh, this is the walkthrough. Okay, so if we go back here, we're doing regression, so let's add down here 4 categorical features to prevent overfitting. Alright, save that. And let's see, does that improve the model if I do that again? So I'm going to exit out of the walk forward. That's going to make everything else go slow. There's the performance from the last model. Now let's do Model Explorer. Is Model 15 still turned on? Make sure this is saved. Go back here. Let's go to Model 15. Model 15's turned on. And then I'm going to add an alias for the sector feature so it doesn't give that weird naming. And then I'll say alias is equal to sector. Alright. Let's see how that does. Okay, now I don't think my data set contains any missing values. How I currently have the data in a pandas data frame called df, write some lines which will test if it has missing values. If no values are missing, I'm not going to bother with the feature engine update. Okay, so now let's pull up the data. Python, ooh, am I running it here? I did, oh yeah, it's running. All right. Python 3, import pandas as PD, df is equal to PD dot read CSV. Let's read dot dot slash data slash sectors info dot CSV df. All right, now let's paste the code. Total missing values is 1. Really? Okay, I guess I'll just add it. What lines were changed in the feature engine code and what lines were kept the same? Yeah, of course. Please. And let me know how it goes. Let me know how I can improve it. I'd really appreciate that. Alright, so now I'm going to put this in. So 1.3 in feature engine. And this guy's running, let's see where it's at, trial 32, so it'll be done soon. I'm just gonna, once this finishes, I'm gonna check out how it did and then I'll go on to the next thing. Alright, come on, hurry up. Okay. Now let's do okay, I'm gonna update the repository. So I changed, what did I change? Clean analysis and feature engine. So updated hyperparameters to avoid overfitting to categorical columns. And then here, handled missing values in sectors logic. So still worse. Here's the feature importance. Good. Now it's just sector. But it's still not doing. It's still the most important feature and still didn't improve performance. So let me run this one more time with the new fixes. See if that improves anything. I implemented the changes, but the model is still performing significantly worse, and the sector feature is still the most important. What is the cause of this, and how can I fix it? It is my intuition that adding the sector feature should improve model performance because it is uncorrelated to all other features which rely on price data. Assess all of this. Tell me whether my intuition is wrong and assess why model performance is worse, but sector feature. So I think it's going to say the same thing as that it's overfitting. Let's see. Your intuition is failing here because it assumes the relationship between a sector and future returns is stationary. Okay, so gain. Alright. Because this split works flawlessly across millions of rows in your training set, LightGBM assigns sector the #1 feature importance. Why it fails in the test set. When your test set rolls around, the market regime rotates. Okay. If you want to use sector data to improve your model, yeah, so that's what I'm doing next, sector neutralization. You can modify phase 3 of your feature engine. I want to add, okay, so there are several transforms I am using in feature engine. Currently, all transforms neutralize with respect to the whole market. Write in logic which will neutralize to sector, which works on all transform with respect to the whole market. Write in logic which will neutralize to sector, which works on all of the transforms, not just one. What is the difference between zero sugar and sugar-free? I've never figured that out. I think it's just some marketing crap. Okay, so this is with the with all the changes, and the T statistic actually is good. Oh no, I want 1.96, not 0.96. So all of these are worse. I think I can include that. This logic automatically detects if you requested a sector feature, if it finds one. Since the sector feature degrades model performance, I don't want to use it, and therefore the model the feature engine shouldn't rely on this feature existing. you can get the sectors from /data/sectors info.csv. Use this file to neutralize to the sectors. The head of the first few rows are below, so you know what the data looks like. Sector data. Okay. They don't charge you for the sugar part. That's what 0 means. This is a highly professional approach. Okay, thanks for the compliment, Gemini. Make it diverse so that I can pass in an argument for the feature request class, which tells it to neutralize to either market or sector. Sector data lags quite a bit for day to day. It's typically better for investing in longer trade horizons where they might help in regime determination on a shorter basis. Even sector neutralization, I'm doing day to day. I wasn't able to get a good model. The current model is predicting 5-day forward returns. Not like regimes are going to change a lot every few days, but it also seems like that would be better if I'm if like one sector is performing really bad on one feature, then it will give bad values for all the model. I mean, maybe I want to give features which are neutralized to sector, and at least I think I want to, train the return to be relative to that. Hey, Sing, I haven't seen you for a while. How are you doing? And what do you mean it lags behind? Sector data, like there'll be a new stock listed and then you can't get what sector it's in, or because I assume stocks aren't changing sectors very often. Alright, so update the feature request class. Give me only the lines which I need to change. Explain what they are doing and where I need to put them. Period. Here are the exact 4 blocks you need to change in feature engine. Add neutralization to feature request. Transform params. Okay. Feature request. So after transform params, so neutralization should be market or sector. Transform performs relative to this parameter. Save. Generate the final name. So, Oh, sector. Yeah, so it adds that at the bottom. Okay. Auto load sector data around line 604, right at the beginning of phase 3. Checks if any of your requests. Hey, thanks, Faster Than AI Tiger. I appreciate it. Aren't you playing the markets during these rare war times? Yes, I am. I've bought a bunch of oil. So we have to see, what's going to happen April 6th. Is there a peace agreement that's going to happen? I personally think it's a fake peace agreement. I think basically the only top two options for the U.S. is withdraw and say no more meddling in the Middle East, which would be good and actually in accordance with Trump's campaign promises. The war is not. But I think, why is he doing the war? It's got to be, because this is what the hidden government wants, and so, the losing the bases in the Middle East would be a huge strategic loss for the U.S. So I don't think we're gonna go for that. I think Iran is saying we could just sit and fight and keep the Strait of Hormuz closed indefinitely. So we're gonna do that until you get out of the Middle East. Maybe they'll come to some peace agreement. I don't really see that happening. But, and also this is in Trump's playbook. We're doing peace talks. We want peace. And then, how many times has this happened where then there are the peace talks. And remember Maduro? He held that press conference where he said, peace, peace, peace. Sector data is typically calculated at end of day after settlement or index rebalancing. Doesn't the sector shouldn't change, right? The sector for a stock should be unchanging. From day to day, it should be the same for every day. Why would the sector data change? So what did I add? Autoload. Generate the final name. Okay, so that's what I just added. Then autoload sector data around line 604. Keep track of the base columns that were transformed. Okay. Phase 3. Anyway, that's what Iran could just keep the strait closed indefinitely. As far as I could see, maybe I'm missing something here, but and I think the best, their terms are so far apart. The U.S. says we want unconditional surrender from Iran. Now, obviously, we would accept less than that. That's just Trump saber rattling. But we want something big. sector performance changes. Yeah, but since I already have the price data, like I'm taking the features from the price data, and then instead of neutralizing to the whole market, neutralizing to the sector instead. Um, so the sector performance changes, but I'll have all of that in my price data. So as long as the sectors don't change, it should be incorporated, right? Let's add this guy here. Um, yeah, but they could just keep the Straits of Hormuz closed. Yeah, so I think the terms are so far apart. How do you protect against options falling value because of a sudden VIX crash? How do you play the VIX? I don't know enough to really play it. I just look at it. What's the volatility right now? Um, yeah, well, it's basically unwinnable. It's like every Middle East where this is what pisses me off so bad is, I thought Trump was aware of this, that Middle East wars are a terrible idea. And yeah, we have the best military in the world. We have the best technology. We could whoop anyone on paper in a total war, but we never do total war. So we're basically have our hands tied. We don't want total war with some country halfway around the world, the people. Um, so every war in the Middle East is unwinnable. And here we are again. But, the terms are too far apart. Iran says we want you to completely withdraw from the Middle East. The U.S. says we want you to capitulate. How can they come to a deal? I can't imagine any sort of deal that's going to work for everyone. But I will say, Trump is good at threading the needle. So maybe he's going to find something. But as far as I could see, I don't think we're finding anything. So I'm in on crude oil. I'm a crude oil man. And crude oil did really well today. But we'll see. Maybe they come to some deal. Crude oil crashes and I lose my trade. I lose money on the trade. But I can't wrap my head around how that's going to happen. And from my experience, if you can't wrap your head around something, uh, you know, uh, you use that in the market. So I added that, right? Yep. Oh. That was already happening. Replace with this. Checks if any of your requests asked for sector neutralization. If so, it quietly loads the sector CSV. Okay, cool. Computing transforms and targets. Okay, we're good. Apply the dynamic grouping, phase 3 loop. Find apply transforms. And replace with this. In step 3, you're changing it so that it neutralizes to... Yeah, I did see that. Enlistment age raised to 42. So we'll see if I'm going to get drafted. I'm 29. Are you in the age range? Are you going to get drafted, Sir Night Knight? But honestly, are they going to do a draft? If they do a draft, there's going to be riots in the streets and Trump's going to be impeached. I don't see any way that happens, honestly. You'd have to be like, I know Congress, basically the Republicans in Congress go with whatever Trump does, but I do not see a way that he doesn't get impeached if we have a draft. Maybe I'm missing something here, but it's basically the United States falls to a totalitarian state, um, or we're not having a draft, and Trump's getting impeached if he tries it. But yeah, I did see that. If we have a draft, I'm gonna be a conscientious objector. No, I haven't heard of that, but that sounds interesting. Skinny on options math. I'll look it up. Is it a YouTube series? All right, I need another drink real quick. First, I'm gonna put this prompt in. So in step 3, you're changing it so that it neutralized to sector instead of date. Let me look through that. So it's neutralizing to sector instead of date. If we have the transform, we're grouping by CS group is date macro sector. Oh, never mind. This should work well. I was confusing myself. So apply transforms. Okay, rank, D-mean, and CSZ score. So I'm replacing everything below this. All right. If we have sector as the neutralization, we're gonna group by neutralization, and we're gonna group by date and macro sector. If it doesn't, then we're just grouping by date. Okay, and then we perform that. Group by CS group. If okay, so that's in there. Drop the base columns only if they weren't explicitly requested. All right, copy. All right, so that's fine. Drop the base columns only if they weren't specifically requested, and replace this guy with that guy. Okay, so this should be good. Now look over your suggestions to ensure there are not any errors, and justify and give me your conclusion. Reason from first principles, and give a justification for the conclusion. Okay, it's a video podcast series on Tasty Live website which teaches the statistics and other math behind the option world. I've never gotten into it, so that might be an interesting thing to watch. I wrote it down. But yeah, I've never gotten into options. Sometimes I buy options, but the math behind them I don't really understand that well. I mean, there's like a formula, right? Formula for calculating option value. But yeah, I've never learned that. All right, so let's see what this says. I'm gonna go get another drink really quick. I'll be right back. Hey, buddy. Hey, you're back. Yeah, I was just about to start. I was gonna make chicken piccata.
Making what?
Chicken piccata with a side salad.
Okay. Sounds good.
All right. All right. Code is error-free and structurally sound. That's good enough for me. Okay, so now we've incorporated all of this, and let's do the same thing, but we're gonna, first I'll do model 12, but only model 16 is same as model 12, but normalizes target to sector. And then I'll try that, see how does it do. Does it improve? And then I'll try same as model 12, but normalizes all of the features to sector. So if first we're going to add a test for model 15, test model 16 is equal to true. And then here, okay, so model 16. If test model 16 is equal to true, let's go through. We're going to do the same thing as model 12. So let's find test model 12. Add all of the same features. And the target, I'll just copy the whole thing down. And I don't have the categorical. Okay, so I actually have a bunch of things to do right now. So that's the first thing I'm going to do, and then target is this guy, feature request, and then after the transform, we're gonna do so feature request. Where's that defined? After the transform, I'm gonna say neutralization equals market. Whoa. Okay, so here I just have to say self.neutralization is equal to neutralization. Okay, so that will work. And then here I'm just going to pass in neutralization is equal to sector. Okay, so now I'm going to test it and see, does this improve the performance? So let's add to the PowerPoint a new slide. Oh, this is with embargo because it was performing better. Now if we go here and say does neutralizing target to sector instead of market improve model 12? Make this guy smaller. neutralizing to market, and then I'll put the other results here. Neutralizing target to sector. Sequoit or sector. Alright, where's it at? It just started the trials. Oh no, I didn't turn this on, did I? Target. Neutralization is sector. Now this is test model 16. Okay, I don't want to test model 15 anymore. Okay, so this was doing model 15 first, so let's exit out. Run it again. Now we'll do model 16. And let's see how it performs. I should get better performance, I'm hoping. Relative to sector. Yeah, so sector won't be a feature here. Alright, what do I want to do next? So next I'm going to try neutralizing all features to the sector. Yeah, and then I need to look into the universe data to how can I make the universe data better. But this should, it should work still on the old universe data. I should see if the performance is better with the sector neutralization. I'm going to go with that, and then I'm going to try to optimize the universe data to get the best results, because currently I'm including things that I don't want to include because they don't have good price movement. So I'm going to do some tests here, whether they work well or whether they don't work well. The next step is going to be I'm going to try to improve the universe to get better performance. So model 17 is same as model 12, but neutralizes all targets and feature to sector instead of market. Okay, so let's write the code for that. Oops. Oh, my mouse is moving way too fast. Model 16. Copy. And let's put this here and call it model 17. Let's make a Boolean to turn this on. Already did that. Okay, so now I need to add this into every feature. So there's that. There's that. Oh, don't need to neutralize this stuff to the sector. Neutralize, 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 neutralize. This is kind of boring, but I gotta do it. Good. So after the current test, I'll do this. What do I? Yeah, the next thing will be working on the Universe Explorer, and or so earlier. I guess I was off stream, but I was trying to add another filter for the universe, which will filter things out. But the trouble is, I'm having trouble defining. So there are different stocks that I don't want. So I need to figure out what are all of those. Orthogonalizing the feature space. Okay, yeah. Oh, whoa. To use sector data effectively, you must structurally force the model to ignore the macro regime. By neutralizing your features within a sector, the mathematical mean of every single sector's, the model is completely blinded. The conclusion, this transforms the non-stationary macro variable. Oh. Yeah, obviously. So here's the performance. Regime stuff is still the most important, so I guess I forget what log ATR is. But regime, moving average crossovers, exponential moving average. So the first isn't a regime feature, but the next three are 0.0203. So it's performing worse. Interesting. So let's close out of this. This guy looks alright. It's performing worse, but it'll be interesting to see how does this do on the walk forward analysis. Long short spread, so it did really poorly in this month. Oh man, it would have done poorly over the beginning of 24. So I want something more stable than that. Yeah, well, anyway. God, I need another drink again already. Let's think. So I'll just put this into the PowerPoint. We can think in a sec. Next, I'm going to run the new model. So neutralizing everything. So if neutralizing the target doesn't improve the performance, neutralizing features to the sectors, that is surprising. Okay, so let's leave this in for now, model 17, and let's run it again. Oh, we need to document this. And this should have saved as model 6, but or model 16, but it didn't. So let me change this real quick so that instead of overwriting model 12, we're saving it as a new model, so 17. Let me make sure it's in there. Yep, good to go. Now let's run this and see how it does. Alright, so now I'm neutralizing all features to the sector and the target to the sector. I'll just copy this. Delete this stuff. Don't tell me this is frozen. Good. All right, so I'm going to see how that performs. Is there anything else I can do? I guess I want to know neutralizing the target to sector performed worse than when I neutralized the target to the whole market. What is the cause of this? That's another trap. Yeah, okay, I get it. Sector neutral target is only useful if you're running a strategy where you allocate exactly certain amounts to each sector. As if you're just buying the top 50 stocks in the market, a sector neutral target will destroy your returns. Features are sector neutral. Target is market neutral. So what? Okay, it's run. Here's the importance. Okay, this looks better. The first two are regimes. Okay, and these are worse. All right. And this looks like shit. So, okay, now I'm going to try. Go back here and I'm going to remove the neutralization on the target, but keep the neutralization on the sectors. So target neutralization should be market, which is the default. So I'll just take that out here, save it. Let's put that in. Make sure I saved this. Now let's run it again. And let's see how it does if I'm neutralizing the features to the sector, but neutralizing the target to the market. I'm going to go get another Dr. Pepper. All right, let's see how this does. Now, the two things I can do to improve this further. Okay. Um, if all right, so I think it was worse. 0.01, 0.02. Okay, so I neutralize all features to sector and neutralize target to market. This performs significantly worse than if I only neutralize target and neutralize target to sector as well. This performs significantly worse than if I only neutralize target to sector and neutralize features to market. What is the cause of this? Trial 17, so that'll be done soon. Touches on a phenomenon known in factor modeling, throwing the baby out with the bathwater. To predict which stock will beat its sector, the model needs to know how to win the race. However, the traits required to win the race change depending on the condition of the track. What happens if setup 1, everything sector neutralized? Because you erase the sector's base rate, the model has no idea if the sector's booming or crashing. When your features are only in market. Okay. The target defines the goal. By making your target sector neutral, you told the model your goal is to find the best stock. By keeping the features market neutral, when you sector neutralize the features in setup 1, you took away the model's ability to see the sector's macro environment. Okay, so this is also performing worse, but better. Less orthogonalized features, so the nonlinear algorithm can use macro environment. So how should I do this? I need macro features. What if I use all the same features and neutralize half to the market and half to the sector? What if I use all the same features, market neutralized, then add the same features neutralized to the sector? Would this perform better or worse than adding okay, so yeah, what if I tried that? Would this improve the model? So I'm not going to make a new slide for this. I'm just going to make a note and say note, I also tried a market neutral target and sector neutral features. This performed better, but still significantly worse than model 12. Okay. I tried sector neutralization to improve my model. I tried normalizing target to sector and features to market. I tried normalizing features to sector and target to market. I also tried normalizing both to sector. All of these strategies performed significantly worse than if I I keep mixing up my terminology here, but neutralized both to the market. If I add in the all features as market neutral, then include the same features neutralized to the sector, will this improve my model? If not, what can I do to improve it? Question. Okay, so let's see what it says. Feature engineering. This is where the biggest gains come from. Rather than repackaging existing features through different normalizations, ask whether you're capturing the right dimensions of return prediction. Some high-impact feature categories you may not have yet included cross-sectional momentum. I did. What the hell is up? Some high-impact features you may not have yet include. Oh, I guess that's shitty grammar though. It sounds like shit. Some high impact feature categories you may not have yet include cross sectional momentum, short term reversal, volume surprises, volatility regime changes. Target engineering often has more impact than feature work. What's your current target? If you're predicting raw forward returns, try forward returns. Temporal validation. Alright, the feature set's gonna be a long thing to give it. Oh man. Let's make this green. Alright, let's think. So neutralizing to the sector doesn't improve things at all. This makes it seem like including sector information doesn't improve the model at all. Is there any way I can use sector info to improve my model? Where'd my headphones go? Sector is a categorical feature. Yep, that didn't work. Sector relative features. Rather than neutralizing everything, selectively create sector relative versions of features where the cross-sector comparison is economically meaningful. For example, sector relative valuation. Add sector momentum as a continuous feature. If you don't currently have feature engine, tell me and I will give it to you. Okay, so let's give it the features. Yeah, I know. I know I don't have fundamental data. Run your shadow feature test or permutation importance to identify which. I guess I could do that really quick. Model 12. Model 13 is this just with the reduction, right? Okay, so model 13. Model 13. Which feature selection method, PCA, shadow, analysis, Kuhn-Johnson, will perform best? Cool. Shadow analysis. So let's get rid of that guy and apply this guy. Oh, train model. Split data. Train model. Okay, if we don't have the params, we'll tune them. So let's get rid of the previous run. Oh, what is this? Oh, this is what I just ran, but it's performing worse. We already know. Whoa! It's negative on everything. Yeah, so let's go back to this. So model 13, model 12, model 13, shadow feature selection. So let's go back to model 13, turn model 17 off, and turn model 13 on. Invalid file path. Gave it the wrong universe path. Oh. So when I'm calling the model, I want to say model init universe path. So I'll say this is the universe path. Don't do that anymore. Now let's pass in universe path. Equals universe path. And then we'll say model folder is equal to dot dot, is it in? Do I specify the model folder above? Yeah. Model 13, model 13, model 13, where are you? Model 14, model 13. Model folder is dot dot slash data slash model 13. Okay, that should work now. Model 13 is on. Okay, let's run it. So the next thing to, oh yeah, so this is, does the shadow feature reduction actually improve? Yeah, but I'm leaving out fundamental data. So, what's today's date? 3/27/2026. Model improvements to try. Out of volume at 2 to 3 market level. Market return and market volatility. I'm already doing this. Improving features. Okay, indent all of these guys. Then let's say another thing. And then adding new features. Fundamental. Previously, I had determined that I couldn't use fundamental features because, tell me again, what are the types of stocks that I want to remove from my universe? Move everything except common stock, ADR, and REIT. So I'll say keep these guys. Keep those guys and remove. Alright, let's just write them. Remove those guys. So remove ETP, equity, WRT, closed, and fund, unit, right, MLP, royalty, TRST, whatever that is, LTD part, tracking, STK, NY, reg, SHRS, test tickers. Alright, then adding new features. Previously, I determined that I can't use fundamental features because okay, here are the results once I'm doing the feature reduction. So it did reduce a lot of features, but I don't know if those are being reduced or just dropped out of the LGBM. I see 0.0242. So about the same. 0.1163. Yeah, so let's see. Did this improve or not? So let's add a slide. Redoing shadow feature reduction on model 12. Alright, and then here's the performance. So this is without feature reduction. And then over here we have with feature reduction. Alright, so which performs better? IC 0.0242, yeah, it's worse. Standard deviation is better. ICIR 0.0986. Whoa. Whoa, way worse? Annual, way worse. T statistic. Wait, is this what that's the wrong thing. Right? Yeah. I think that's 0.0986 for ICIR. What is this? Oh yeah. So IC is worse. Standard deviation is slightly better but not significant. ICIR is worse, both daily and annual. T statistic is worse. Oh, what the hell? Wrong slide. T statistic. Yeah, so this is the correct one. So let's put one of these guys in. Conclusion. So next I need to redo analysis where I drop features one by one. Previously I determined that I couldn't use fundamental features because the data set was missing many tickers. However, are these tickers ones which do not include fundamental data? For example, test tickers. Okay, so I tried a bunch of things. It turns out the sectors actually don't improve model performance. That's okay. I'll figure out a way to improve the model performance. But that's it for this stream. Thanks for watching. Subscribe if you haven't subscribed. And that's it for now. Have a nice rest of your day. Adios. include fundamental data. For example, test stickers.